So let's look again inside the box and let's look at the memory. That's also a very fundamental component of the computer. So the main memory of the computer is called Random Access Memory, which is abbreviated to RAM, RAM memory. So according to the von Neumann architecture, the RAM stores temporarily both the instructions of the program that are being executed and the data that these instructions need to execute. So the positions of the memory are like postal boxes. Each one of them is identified by a number and it contains a sequence of binary digits in them, which is called a word, and this is of a fixed length. So to access, the access time to any memory location is the same, and the access time is independent of the address. And this is actually why it's called random access memory, because it takes the same time to retrieve the information from any random address. This is different in other storage media like a hard disk or a CD, because there actually the disk has to rotate to arrive to the designed position, and then the access time varies depending on the position where the information is on the disk. So another important type of memory in the computer is ROM. This is an abbreviation of read-only memory, and it's a type of memory that is recorded by the manufacturer and we can only read it. And the advantage of it is that the contents is never erased. So ROM memory plays an important role in the boot process of a computer. Since the programs it contains are the first one to be executed, and so they check the computer components and load the operating system to continue the starting process. And since it's read-only, this content is never erased. So there's another type of memory, which is CMOS memory, and CMOS stands for Complementary Metal Oxide Semiconductor, CMOS. And this makes reference just to the material it's made of. And this is very low power memory. And so remember that RAM memory is volatile, it stores content temporarily, and all the information that is stored is lost when you power off the machine. So to keep some information about basic hardware settings as the dates and time and things like that, a small CMOS memory powered by battery can be used to remember these things for the next time you start up the computer. So there are several types of computer memory, and each one of them has obviously its advantages and disadvantages, like everything in life actually. There's always a trade-off between price, speed and persistence, and you cannot, for example, have memory that is and cheap and fast and permanent at the same time. But if you need these three characteristics to make a computer run. So this is why a memory hierarchy is established in a computer, and you put fast, expensive and small storage options close to the CPU, and slower but larger and cheaper options further away to do this compromise. The first level of the memory hierarchy after the CPU registers is actually the cache memory. So if you want a computer to be fast, you need fast access to the program instructions that you need to execute and the data that is needed to execute them. So fast memory is expensive, so cache memory was created as a mechanism to have faster access to program instructions and most used data without spending too much memory. So the data you would read from memory and put into the registers would come from the cache. Cache memory is just a small amount of RAM memory that the CPU can access very fast. And it uses an algorithm to select the most frequently used data and stores copies of it. So most of nowadays computer processors integrate cache memory in the CPU chip and having independent caches for instructions and data. And data cache is usually organized as L1, L2, L3, and this depends a little bit on the speed. So the next level of memory hierarchy is RAM, that we've seen, the random access memory, and this is known as the main memory or primary storage memory of the computer. It's fast but volatile, so as we said, you need another level in the hierarchy that is slower but can be permanent. And there you have, for example, your magnetic and solid state hard drives that are also known as secondary storage, where you can keep the data and it will not disappear. So in most personal computers we have a lot of different applications opened at the same time, but we're not really multitasking. We're actually switching between them. So when there is not enough RAM memory left, what the operating system does is a clever trick which is called virtual memory. And this consists of setting aside a certain portion of storage on the hard disk to act as an additional RAM and moving there the content of the memory of the application that loses the focus. And to bring back into RAM when it gets focus again. So this way the operating system can work with a virtual memory space which is much bigger than actually the physical RAM memory it really has. And this is actually one of the reasons why sometimes your computer freezes for a short time when you switch from one application into the other. Because actually what is done in that time is reloading the memory content from hard disk into the RAM memory. And to manage all this process, the operating system organizes memory assigned to different applications in pages that can be moved between RAM and hard disk. And this is called memory pagination. And the files where RAM content is stored in the hard disk are called page files or just swap files. So this has been the memory where we looked inside the box of the computer.